Hi guys! Welcome to Environmental Systems and Societies Topic 6. In this topic, we are talking all about atmospheric systems and societies. And if you are following along in the textbook, you'll notice that I combined the 4 sections in this chapter into just 2 sections. So today, in Introduction to the Atmosphere, we are also going to be talking about stratospheric ozone because it's part of the atmosphere, and I thought that made sense. And then in the next class, we are going to talk about both tropospheric ozone, photochemical smog, and acid deposition, because all of those things pollute the atmosphere really significantly, and I wanted to address them together. So let's get started on our introduction to the atmosphere. First, it's important to understand that the atmosphere is a complex dynamic system with a series of separate parts. You can see here the breakdown of the atmosphere into its layers. The troposphere is closest to us. The stratosphere is the layer above that. The mesosphere is above that, and the thermosphere is above that. So Earth's atmosphere altogether extends a little bit more than 1,000 miles above the surface of the planet. And all of the substances that exist in these different areas can interchange between the layers. So when we create pollution down in the troposphere, it has the ability to travel up into the stratosphere, for example. We have a pretty good idea of what the Earth's atmosphere has been like in times in the past, because we can do ice core samples and measure what the carbon dioxide concentrations in the air were like from the carbon dioxide that is captured in the ice. And through those studies, we know that there is a pretty significant relationship between carbon dioxide in the atmosphere and the temperature of the surface of the planet. So for that reason, atmospheric systems are really important to human populations. One of the things that does a lot to regulate the temperature of the planet in the atmosphere is the stratospheric ozone layer. And in this topic, we're going to talk about 2 kinds of ozone. Stratospheric ozone is the good ozone. It sits right about here in the stratosphere, and it protects us from UV radiation that is coming down from the sun. So this ozone layer is in a state of dynamic equilibrium. Oxygen molecules are constantly being broken apart to form, I'm going to do just a little picture here. So oxygen molecules exist diatomically with 2 oxygen atoms. When they break apart, sometimes oxygen can form a triple molecule that's a sort of unstable, weak molecule that we call ozone. So this ozone is being formed and broken down constantly in the ozone layer, but the overall concentration of ozone molecules remains about the same, and when UV radiation comes in from outer space, it is reflected off of the ozone layer. So it's super important for us because if there is too much UV radiation, there can be a lot of negative effects. So some of the negative things that can happen because of UV radiation are listed over here. Genetic mutations and cancer. Skin cancer is caused by UV radiation being absorbed too much on the surface of your body. There are some positive effects of UV radiation, but these are really negligible compared to the negative things that can happen when we get too much UV radiation in the planet. So it's crucial that the ozone layer protects us from that radiation. And in the past, we have developed substances unknowingly that have gone up into the stratosphere and started to break down the ozone layer. The one that you hear about the most is chlorofluorocarbon, or CFCs, also known as freons. They were developed primarily as a refrigerant in the 1950s because before that, refrigeration was actually really dangerous, and you would put these sort of unstable nitrogen compounds in your icebox, and it could keep your food cold, but it could also light on fire and burn down your house. So initially, people were really excited about this use of CFCs as a refrigerant. And then industrial complexes also realized that you could use CFCs as a propellant. So you could put a CFC compound into something like an insulation, and it would blow it up and make it bigger. CFCs are pretty stable at the tropospheric level, so people didn't really understand the havoc that they were going to wreak in the ozone. But what happens when CFCs get up higher in the atmosphere and closer to solar radiation is they can release chlorine atoms. And those chlorine atoms can break apart the bonds in those oxygen molecules and also in the ozone molecules. So you have chlorine atoms interfering with this sort of dynamic equilibrium that exists between oxygen molecules and ozone. When a chlorine comes in, it will kick one of the oxygen atoms out of this ozone compound. That oxygen atom will go and disrupt another molecule, and the chlorine atom will do that as well. So this feeds into a positive feedback loop where once these types of atoms, and it's not just chlorine, bromine and some nitrous oxides also do this, they exist in the stratosphere and continually break apart ozone. So once we figured out these ozone depleting substances and how fast they were having an effect on our ozone layer, we knew that it was time to take action. And the good thing about the destruction of the ozone layer is it resulted in what's widely regarded as the most effective piece of environmental legislation that has ever existed in the world. And that is the Montreal Protocol. The Montreal Protocol was spearheaded by the United Nations Environmental Program in 1987, and it existed to phase out CDCs. And basically, the global community came together and decided that the first world nations were responsible for this phase out first and needed to do it immediately. And then third world countries would have between 15 and 20 years to catch up. So in looking at these levels of management, this is a good example of a legislative policy regarding the release of pollutants into the environment that was really, really successful. And for your homework, you are actually going to look a little bit more deeply into this policy. So if you're following along in the book, I'll say again, this is going to cover two sections of the textbook. We're combining 6.1 and 6.2. So you'll read about Introduction to Atmosphere and also Stratospheric Ozone. And then for a comprehension question, I'm asking you to describe the problem of ozone depletion and evaluate the role of national and international organizations in reducing the emissions of ozone-depleting substances. So this is worth 6 points, and there's two things that you need to do there. First, to describe the problem, talk about what was happening, and then to evaluate, and so remember that is benefits and drawbacks, the role of both national and international organizations in dealing with reducing ozone-depleting substances. So give that a try, and when you are ready, move on to the review video to go over your responses, and I will see you there.